Because in a lot of discussions that exist over the category of personhood, which is a term that's used by Dan Dennett, later by Marianne Warren, and sort of this contentious thing in ethics, there really isn't a whole lot of discussion of the neurology. The only really relevant discussion of the neurology applied to ethics that's good philosophically, I think, is Churchland, but there's some other interesting ones out there. So it's worthwhile for a second to take a sidestep to brush up with some of the neurology that I care about. The first is with respect to urge to care, which Churchland describes as being influenced primarily by the limbic system. And most sort of data bears her out on this. I mentioned earlier that I think the limbic system is important for decision making. That comes from a guy named Antonio Damasio down at USC. Damasio had a patient, the extent of these case studies is kind of fishy, but he had a patient who had damage to part of the limbic region of the brain. And the patient had a perfect ability to sort of represent possible decisions that the individual, the two possible options. There are two options, restaurant A, restaurant B. He can represent them, he can represent all the consequences. Well, the food is better here, the crowd's may be lighter here, and can go on listing pros and cons. When asked to make a decision between the two of them, all of a sudden he can't. He can't make a decision, he can't make a value judgment based on pros and cons of those options. So I argue that urge to care is very important in being motivated by the limbic system. That's important for socialization. But it's also important very generally to decision making, not just to strictly whether or not you care about your offspring or your uncle, or even like larger kid circles, like people you don't know, like, you know, Sam or something like that. So we can kind of see some sort of relationship there when we look at lesion studies, and I'll come back to those in a little bit. The second is the capacity for prediction, which generally is described in terms of the prefrontal cortex. There is a lot of dispute about whether that's the right way to approach it. There's a lot of dispute about whether you're allowed to talk about brain states in terms of particular regions, because it's its own thing, and there's a lot of cross-wiring and all sorts of other things going on. But it does seem that damage to the prefrontal cortex does damage ability to represent future states of affairs and understand all the causes related to any particular action. It also plays a really interesting role in delaying gratification. So instead of just choosing an option which seems immediately desirable, the prefrontal cortex allows you to do things like control your bladder and intervene in lower level brain functions. So while we're participating in cognitive processes that require advanced consideration of partial implications, there's an increased activity in the prefrontal cortex. All that says is when you're engaging in mental tasks that are, you know, require some sort of advanced planning or higher order processing or whatever, there's increased activity and there's some correlation between the two. I think the lesion studies indicate that damage to the prefrontal cortex also limits the ability to do planning. And if that's the case, then there's some sort of necessary causal relationship, at least in adults. This is going to run me up against some problems when I start talking about kids, because we have to start talking about some other stuff. There are sort of two ways of doing the argument that I can do. My original version looked like this. If S has some neurological structure mu, then S has cognitive capacity C. 2, if S has cognitive capacity C, then S is an agent. 3, this is my conclusion, therefore, if S has mu, then S is C. This is sort of like what's up here. But I have no problem with this kind of form, and I think there's good reason to believe that in the long term we'll probably end up with something like this, and I'll probably be comfortable defending it. But for right now, actually, the form that I've taken is something different. I've actually taken to phrasing this particular set of syllogisms in the negative, at least when it comes to adult cases. And what I mean by that is it looks something like this. So this is the positive. The negative argument, which is a little weaker, but I think more defensible, at least at this particular moment, is If S does not have neurological structure mu, so if not mu, then X does not have cognitive capacity C. 2, if S does not have cognitive capacity C, then S is not an agent. So if S does not have cognitive capacity C, then A is not an agent. 3, therefore, if it does not have mu, then not an agent. Okay, so let's say there's a subject, adult subject, Albert, who has, for most of his life, a normal range of neurological functions. The reason I'm supposing this is because it gets me around some issues with maybe he has a developmental disorder or something like that. So he has a full range of neurological and cognitive functions. We say, okay, Albert's an agent. He functions normally in society. He, walks around. He talks to you. He can make decisions. He doesn't go around, doing things that are not generally sociable, but also doesn't violate kind of standard social norms like. But based on his neurology, we have no reason to believe that he would be excluded from this category. He doesn't violate this and get excluded from being an agent. Well, okay, so Albert gets trampled by a rhinoceros or something. Not totally destroyed, but destroyed enough that he lacks these particular mental capacities that I'm talking about. We understand that he's missing the mental capacities based on the destruction of the neurological capacities. They're generally considered identifiable, though I'm not sure that we want to make that jump in neurology. Albert is missing, let me revisit this. So Albert doesn't have the neurological functions because they're destroyed in whatever sort of incident he has that produces brain lesions. We assume that he lacks cognitive capacity C. By lacking cognitive capacity C, he's not an agent. I think that we make this kind of move all the time. I think this is very intuitive. I find it very intuitive. Before I get any more into this is really my basic schema and sort of the standard qualifier for my paper.